All right, guys. For today and into next week, actually a few days, like 3 days, 4 more days into next week, we're going to be working on section 5.3. Michaela, put it away. All right, so in this section 5.3, we're looking at factoring again. So we'll review quickly the factoring we have been doing, so it should be okay there. We're going to then look at factoring things that are x to the fourth versus everything that we factored has been x cubed, or x squared, sorry. So we're going to look at x squared, we're going to look at x to the fourth. We're going to look at how to factor something with 4 terms instead of 3 terms or 2 terms. And then we're going to look at factoring things that are difference in sum of cubes, so like x cubed, things like that. So we got a lot going on in this section. So if you guys still have your factoring flowcharts, you may not need them as much today, but into next week, make sure you kind of dig through your stuff and find those. You're going to definitely need those coming into next week, okay? All right, so first part here, to factor a polynomial equation, first move all the terms so the equation equals 0. Good. Always remember to factor out the blank before doing any other factoring. GCF. The line is so long in case you wanted to write greatest common factor, but I'm lazy and don't want to. All right, guys, honestly, that's probably going to be your biggest thing and throughout this section is remember to take out the GCF first. Okay, the problems get a lot easier if you take that out. All right, once the equation has been factored, set each factor equal to blank and solve. 0. Set them equal to 0, we solve. We do a lot of that in our head anymore. He's just saying the words that are in my mind right now. Thank you, Ramon. Hi, Jacob. Thank you. All right, the blank of the polynomial is equal to the number of solutions or zeros. Nope. Degree. The degree of the polynomial. How do you find the degree? Nope. Well, if I had the graph, yes. The highest exponent. Guys, I don't know what is going on today, but you need to shut your mouths. I'm not happy. This is a hard section, and I don't want to fight you against it today. I know it's Friday, but you need to get your crap together, okay? All right, so the degree of the polynomial is equal to the number of solutions, zeros, roots. Remember that word means the same thing. So like if it's x to the fourth, that's your highest exponent, you're going to have 4 answers. Okay, so we're going to move into stuff after, especially after we learn all this other factoring, where you're going to have to find like x to the fifth, x to the sixth. You're going to have a lot of answers to try to find. If an equation cannot factor completely to linear factors, you'll have to use the quadratic formula or finding square roots when necessary. You could use completing the square, but that's usually not somebody's go-to. So this right here is very new to us. Okay, I mean, I know we know how to solve and do things like that, but if I go through and I'm factoring and it gets down to where it's an x squared and I can't factor it any further, you're going to have to go back to one of your other methods from chapter 4. All right, true or false? The quadratic formula can be used to solve any equation. True or false? I said any equation. I heard a true, I heard a false. Marcus, why'd you say false? Because you're just assuming I'm tricking you? You're right. It is false. Quadratic formula is used to solve any quadratic equation. If I have an x cubed equation, I can't use a quadratic formula. It has to be an x squared equation, then I can use it. So just be careful on that one. Solutions or zeros may be blank or blank. I agree, positive or negative, but that wasn't what I was going for. I agree, but not what I was going for. There it is. That's what I was looking for. Real or imaginary. And at this point, we've been dealing with real and imaginary for quite some time, so hopefully that's pretty second nature. And then just make sure you watch for factors that are not linear. Do you guys know what I mean when I say linear? X to the first, linear. So if they're not linear, they may factor further. So just kind of watch for that, okay? All right. So let's kind of just jump in, getting some practice with stuff that we're a little familiar with before we get into stuff that's a little different. So if I ask you to solve number 1 by factoring. Good. I'll take an X, but also a 2. So let's take out that 2x. So we're left with x squared plus 4x plus 3. Okay, and then can I factor that further? We should always try, if nothing else, right? What are your signs? Good, I heard x plus and x plus. 1 and 3. Will that make 4? Yep, so we know it worked. So if I ask you to solve, x is going to equal 0, good, and negative 3. My original problem started out x cubed. How many answers do you have? I do have 3. Okay, so always just kind of do that mental check. Go back to the problem. Be like, all right, how many answers should I have? How many do I actually have? Make sure you didn't miss something. Yes. No. No, baby brother only gives you an answer if there's an x with him. Yeah, otherwise there's nothing. All right, what about number 2? You could move the 2x to the 4th. But I'm going to move everything the other way. Why? Yeah. If I move this, it becomes negative, and then I got to take out a negative, and then I got to watch all my signs. You can, but it's just, I don't know. To me, it's just not as easy. I can move those easier. So minus 5x cubed minus 12x squared. Right, we got to do the opposite when we move them to the other side. GCF? Good. Take out an x squared. So we have 2x squared minus 5x minus 12. Is this one going to be as easy to factor as the last one? No, we got a little more extra stuff going on here. All right, well, let's set it up. What are your signs? Plus, minus. Good. Options for A? 2 and 1, so 2x and 1x. Oh, options for C. All right, so we got some options going in there. I think somebody might have found it already. 3 and 4. If we check this, we get 3x minus 8x. That give me negative 5x? Yeah, so that one worked. All right, so can you solve this for me then? So x equals 0, 0. Very good. Good. And 4. How many answers do I have? 4. That was an x to the 4th. So, I mean, this, we've seen this, right? This is familiar to us. This isn't too bad. And then I just make it awful on you. Today's not bad. It's not terrible. All right. This packet that you have in front of you is like everything for next week, too. So we're not doing all of it today. All right, what about number 3? Move the 6x. Thank you. I try. All right, so we set it equal to 0. Then what? 3x. Okay, so we have x squared, 4x. Good. Okay. Signs. Options for A, 5x, 1x. Options for C. You want to go 2 and 1? Well, I could go 1 and 2. All right, so if I check this, I get 2x minus 5x. Does that give me a 4x? Oh, that didn't work. All right, so flip 5 and 2. So 1 there and 2 there. So that's going to give me 1x minus 10x. How about that one? Doesn't work. Okay, so it doesn't factor further, right? So I was able to factor it to here. My directions are still to solve. If I distribute, I go right back to where I started. Well, I know one of the answers right now, right? One of the answers is 0. All right, so it doesn't factor. Chapter 4, I'm pretty sure we covered 4 methods to solve. I'd go quadratic formula next. Oh, yeah, all that stuff, you know, math, it keeps coming back over. I'm sorry. All right, so you remember quadratic formula? Negative b, so negative 4. Well, look at that. So we tried to factor and we couldn't. So if you can't factor, then you got to go back to something else you know how to do. We can use quadratic formula. Could I have just used a quadratic formula from the very start? Ah, very nice, Marcus. Yeah, for the very beginning, it's cubed. I can't use the quadratic formula on a cubic function. You'd be way wrong. way wrong. All right, so here we go. So we got negative 4 plus or minus radical. Somebody clean that up underneath there yet? What is it? 56. All over 10. All right, did we do our factor tree on 56? So it's going to be negative 4 plus or minus, is it 2 radical 14? Somebody check me here. It's early morning, I'm half awake. Am I good? Stop there. All 3 numbers can be divided by 2. So we get negative 2 plus or minus 1 radical 14 all over 5. Good, that's 2 answers. Very nice. Plus minus. So there's 2 answers. There's the third answer. I'm supposed to have 3. I got them all. 1, 2, 3. Yeah, because I have negative 2 plus radical 14 over 5 and negative 2 minus radical 14 over 5. That's 2 answers. We're just lazy mathematicians writing it as 1. All right, so kind of let's get this stuck in our heads because this is where people start to struggle. If you're going through and I give you a whole page of problems and you're like factor, and then you hit one that you can't factor, what do you do? Yeah, go back to the quadratic formula then. As long as it's down to a quadratic. All right, that goes back to the step in your notes that I circled and was like, this is a little different. But it's the stuff we know, but it's a little different right here. If an equation cannot factor to linear factors, where you're down to just x plus 5 or whatever, use the quadratic formula or finding square roots. You can use completing the square if you want. But I just know that's usually, typically not people's go-to. But you can. Are you all right over there? Vanessa, you all right? Okay. All right, let's try number 4. What do you want to do first? Move the 3x. So 2x cubed minus 5x squared minus 3x. Take out an x. All right, so we have 2x squared minus 5x minus 3. Plus minus. Options for A? 2x and 1x. C? You want 1 and 3? Okay. All right, so that gives me 1x minus 6x. Did that work? Yep, that worked. So then x equals negative 1/2 and 3. I got 3 answers. How many was I supposed to have? 3. So I know I'm good. So what's faster, quadratic formula or factoring? Way faster. But you wouldn't have said that maybe a month ago. Number 5? Think you can try it on your own? All right, number 5 on your own. I think a lot of you, as you started working through that problem, you thought it was a really nice, easy one, but at second look, it really wasn't as nice as you might have thought. All right, it's already set equal to 0. GCF? Good. 3x squared. So we're left with x squared minus 2x plus 4. So when you tried to factor this, a lot of you went with x minus 2 right away. But that's going to give you a negative 4x in the middle. And if you go with 1 and 4, it's going to give you a negative 5x in the middle. So this actually does not factor further than that. Okay, well, we know right away x equals 0, 0. So I can at least write down those. I found 2 of my answers. Yeah. Because if you would solve that, you have to divide by 3, and it's not going to change it. So here we have to use quadratic formula. So negative b is going to be a 2, plus or minus square root b squared, 4 times a times c, all over 2 times a. So x equals 2 plus or minus, what do you get underneath that radical? Good. Over 2. Simplify the radical, so 2 plus or minus, it's going to 2i radical 3, all over 2. Divide everything by 2, so we get 1 plus or minus I radical 3 over 1 if you want, but you don't have to. Do I have to write this one? This one's being added and subtracted. Does your adding and subtracting 1 change your answer? Yeah, it's going to change it. Does multiplying by 1 change your answer? Does dividing by 1 change your answer? No. So I don't need those ones, but I have to have that one because it's being added or subtracted. That changes your answer. Overall, you guys look pretty good on those. Okay, so if it doesn't factor further, you're going to have to use quadratic formula to finish solving it. Okay. My favorite way to factor, which for whatever reason some of you, this has escaped you, and I still can't understand why, is your difference of squares. Those are the fun ones. Those are the fun ones. Yes, you have a question. Yes, they are in the grade book. All right, so number 4. What's the first thing you do? Good. Move the 75. So we have 12x cubed minus 75x equals 0. GCF? Three x. Yep, 3x. Ramon. So we get 4x squared minus 25. Ramon. Good. Those are my favorite ones to factor. 2 terms, and they're both perfect squares, so you just take the square root of them. All right. From there, we can actually solve this pretty easily. So x equals, and good. So I'm going to be lazy and write plus or minus 5 over 2. You guys okay with that? I'm being lazy mathematician. Right, we get a 0 from here, negative 5 over 2, and positive 5 over 2. So I just wrote it as plus minus. All right, what about number 5? So I've already said equal to 0. GCF? X squared. You're right with the 1. Nothing goes into them both, but I can take out the x squared. Oops. Hold on. One step at a time. So 9x squared minus 64 equals 0. Now go ahead, Ramon. Thank you, Ramon. So Ramon, can you finish it? What are my answers? What are the answers? I didn't know your name was Ramon, Michaela. I know, right? All right. How are we feeling with all of this so far? Doing all right? No? Difference of squares waved bye-bye to you? Yeah. So far, this is really not much different. This is just difference of squares. All right. Try number 6 on your own. All right, guys. Number 6. What's the first thing you did? Subtract 82. So we get 100x squared minus 81. Is there a GCF in this problem? No, there's not. How does it factor? Good. So x equals? Good. Plus or minus 9/10. All right. So that's all stuff that's familiar to us. If it wasn't, we're in bigger trouble than I thought. Okay, so let's move into something that's a little different, but kind of the same. Okay. So what if it isn't quadratic? What if it's not x squared? Can you still factor things? And the answer is yes, you can. All right. So like number 7, right away, what would be the first thing you would do? Before then, I'd move my 15. X to the 4th plus 2x squared minus 15 equals 0. Is there a GCF? No. Why do I stare at this, though, and it gives me fits? Everything I factor is always x squared. This is not. But take a look. Every time you factored things, like we started out, like you ended up with an x squared and then an x and then a number, right? What's the relationship between x squared and x to the 1st? This is x squared, this one's x to the 1st. Take a look at the problem that we're working on. This is x to the 4th, this one is x squared. It's half of it. So can I still do it? I can do this. As long as I'm looking at here like this is going to be half of it, it's okay, I can do this. So like if this was x to the 6th, this would have to be x to the 3rd. Okay, so let's work through this one. I'll kind of do a little bit more work with this one so you can see it. But we're going to set it up just like we did the regular quadratics. Right? With regular quadratic equations, we set up our parentheses. What are your signs? Plus, minus. Options for A. Instead of x and x, it's going to be x squared and x squared. Options for C? 1 and 15, 3 and 5? Okay. It's 5 and 3. All right, now I want to show you, you don't have to write this down if you don't want to, but I want to show you how this actually works out okay. Because some people are always like, wait a minute, how's that going to work? So if I do a full FOIL on this, so I multiplied it out, I'm going to get x to the 4th minus 3x squared plus 5x squared minus 15. Put your like terms together. X to the 4th plus 2x squared minus 15. Did it work? It works. Okay? So whenever you have something like this x to the 4th, it's just going to break down your options for A. It's going to be x squared and x squared. Other than that, it's not very different. If this was a 3, then you can't do it. Unless you could pull out your GCF and make it a squared. But yeah, so we're looking at, guys, 3 terms. Like we've always been factoring these with 3 terms. If it's x to the 4th, that's okay as long as the next one's x squared. If it'd be x to the 10th, the next one would have to be x to the 5th. It had to be half of it. As long as it's half, it's fine. It works. Now the question is, how do I solve these? Normally, I just kind of do them in my head, right? Well, what's your process, though? When you're doing them in your head, what are you doing? You're setting them equal to 0? So let's try that. Let's just go back to old school when we used to write them down. Hold on. Let's work through it. We'll see kind of what happens. How many answers should you have? I should have 4. How do you solve this? Subtract 5. X squared equals negative 5. So x equals plus or minus I radical 5. So over here, x squared equals, good, so we take the square root. Some of you are a step ahead of me. But plus or minus radical 3. How many answers did I find? I did find 4. Because I have plus or minus radical I radical 5, and then plus or minus radical 3. I have 4 answers. They're not pretty, but I have 4. If you think about what its graph looks like, I'm going to try to kind of tie all this together for you as we're going. If I look at its graph, how many times would it cross the x-axis? Twice. Why only twice? This is roughly like 1 point something, right? If you did its decimal, so that's where it was going to cross. What's it mean if it's an I? It's imaginary. Why is it imaginary? Because it doesn't cross the x-axis here. So this is not going to cross the x-axis, but this will. It's going to only cross twice because of the other ones are imaginary. All right, let's take a look at number 8. No, I'm hot. That's why my sleeves are pulled up. I'm hot. Thank you. Let's move the 13x squared over. Guys, when I move the 13x squared over, make sure you put it in the correct location. All right, it's going to go right in between those. Do I have a GCF? No, no GCF on this one. All right, so no GCF. So as I'm looking at this, can I still factor it because it's x to the 4th? Yeah, because the very next one is x squared, so I'm okay. It's half of it. So if we set up our parentheses, what are your signs? 2 minus. Options for A. Good. 3x squared and 1x squared. And then your options for C. 2 and 2 or 1 and 4. I'm trying to get a 13 going in there. 1 and 4. All right, so if I check this, that gives me a negative 1x squared. It's going to give me a negative 12x squared. And that'll make negative 13x squared in the middle. So that'll work. And then we set them equal to 0, right? Okay, so let's do that. So 3x squared minus 1 equals 0. X squared minus 4 equals 0. And then we solve. So add 1. 3x squared equals 1. Divide by 3. So x squared equals 1/3. Can we, yeah, radicals on fractions, that's top and bottom. So x equals plus or minus, what's the square root of 1? 1. Square root of 3? Can't leave a radical on the bottom. Holy crap, this problem did everything we've ever learned, right? So what do we have? 1 radical 3 over 3. But should you know how to do all that? Yeah, we've done all this. I'm just taking everything you've ever learned and thrown it into one problem. What about the other side? Oh, come on, Marcus, talk me through this. What do I do first? I'm going to add 4. And then how do you get x by itself? Marcus, how do you get x by itself? Yeah, take square root. What's square root of 4? Just 2? Plus or minus 2? How many answers did you find? 4. How many were you supposed to find? 4. So I did all right. So in other words, as you're kind of looking through like your whole process here. So if I'm looking at a problem and I pull out my GCF and I'm left with an x squared that I can factor, I go ahead and factor it. If I pull out a GCF, I have an x squared and it doesn't factor, I'm going to have to use quadratic formula to try to figure it out. But if I'm looking at a problem that starts x to the 4th, I know eventually I'm going to have to set these equal to 0. I'm going to take some square roots of stuff. My square root method's kind of coming into play here. All right, guys, take a look at number 9. Number 9. It's already set equal to 0. Do we have a GCF? They are perfect squares. There's no GCF, but yeah, is that a difference of squares? It is. So set up your parentheses. What are your signs? Plus and minus. And Peyton recognized that. He's like, wait, it's a difference of squares. So it's 9x squared and 11. Good. Yeah, so it's not bad at all. So set each one equal to 0. All right, we have to solve each one. Here we go. So subtract 11. 9x squared equals negative 11. Divide each side by 9. Hold on. Don't go too fast. So x squared equals negative 11 over 9. Guys, not everyone moves that fast. You're not even writing it down, so just slow down for people. So then we take the square root. Fractions are top and bottom. So x equals plus or minus I radical 11 over 3. How many answers is that? Will the graph cross the x-axis with these answers? No, because it's an I. Imaginary ones don't cross the x-axis. That's why they're imaginary. All right, over here, add 11. 9x squared equals 11. Divide by 9. Is this going to be the exact same answer? It's not I. Take square root, top, bottom. So plus or minus radical 11 over 3. Will this one cross the x-axis? Yes. So it's going to cross twice. At these, they'll be lovely decimals, but it will cross. Here, it will not because they're imaginary. Right, they're imaginary. In somebody's mind, they crossed. All right, what about number 10? It is a difference of squares. Good. Plus or minus. And 4. Set each one equal to 0. Then what? Subtract 4. So x squared equals negative 4. To I. Will that cross the x-axis? No, it's imaginary. Add 4. Square root. X equals plus or minus 2. Will that cross the x-axis? Yeah. At 2 and negative 2. When it's a difference of squares like that, yeah, it'll only cross at 2 of them. All right. Number 12. Number 12. What do you do first? Move the 4. So x to the 4th minus 3x squared minus 4 equals 0. GCF? There is not. Okay, we'll set up our parentheses. Signs? What? Last one's negative. So it's automatically plus minus. Yeah, that's back to basics from day 1 of learning how to factor. Yeah. All right, what are your options for A? X squared and x squared. Options for C? 1 and 4. Which one's negative? It's 4. If you check that, the 4 has to be the negative one. Set each of them equal to 0. So when we go to solve, subtract 1. So x squared equals negative 1. Take the square root. What's a square root of negative 1? I. Plus or minus I or 1i, Michaela? All right, solving the other one, we have to add 4. Square root. Square root 4? Plus or minus 2. Okay, so if you get in the habit of always doing that mental check of how many answers you should have versus how many you wrote down, then hopefully that'll help you not forget those plus minus signs. Because if you just wrote down I and 2, you'd be like, I only have 2 answers, but you need 4. So the plus or minus I is 2 answers, plus or minus 2 is the other 2 answers. You guys want to try one on your own? Yeah, try number 13 on your own. All right, guys, last problem for today. What's the first thing you did? Move the 12. X to the 4th plus 4x squared minus 12 equals 0. GCF? No, there's not one this time. All right, so we set up our parentheses. What are our signs? Plus, minus. Options for A. And then options for C. Marcus? 6 and 2. Positive 6, minus 2. Good. Set each one equal to 0. All right, so we have to subtract 6. So x squared equals negative 6. Square root. So x equals. Perfect. Plus or minus I radical 6. Add 2. Square root. So x equals plus or minus radical 2. The radical's still there. Will this cross the x-axis? Will this? Yes. Okay. Yes. Not always. Just depends on the problem. All right, questions on anything else that we went over today? So if you can factor it, factor it. If you get to a point where it doesn't factor anymore, you may have to move into the quadratic formula. Okay, just be aware of that. All right, homework for tonight. I'm going to give you guys a packet that's got all the assignment for like everything we're doing. So we're only going to do bits and pieces of it. So for tonight, you're only going to do numbers 1 to 24. All.